Today I'm going to explain photosynthesis to you. There's two parts, the light-dependent reactions and the light-independent reactions, and I'm going to start with the light-dependent reactions with a little bit of a story. Eddie the electron was glum and unmotivated, just sitting in his room all day long playing PS2, or Photosystem 2. Then a ray of light came in and he said, "At last I see the light." He got really excited and accidentally knocked over a jug of water, which split into an oxygen atom, which got released into the air, two positive hydrogen ions, which got released into the thylakoid membrane, and some electrons, which are going to be used later in the story. He went to visit his girlfriend Edna, who just sat all day playing PS1, or Photosystem 1, and got her excited too. Then energy from both of the excited electrons was used by the electron transport chain to bring the positive hydrogen ions from the stroma to the inner thylakoid membrane. Pigments in PS1 re-energize the two electrons. Then NADP+ picks up the electrons along with an H+ ion and becomes full, or NADPH. Now, that's going to be used later on, but the inside of the thylakoid membrane is positively charged and the outside of the thylakoid membrane is negatively charged, so ATP synthase works kind of like a rotating door and binds ADP and a phosphate group to make ATP, while at the same time letting the positive hydrogen ions across the thylakoid membrane. At the same time, the Calvin cycle is going on, the light-independent reactions, and it's kind of like a carousel because 6 CO2 molecules enter from the atmosphere and combine with 6 5-carbon molecules, making 12 3-carbon molecules. They're all converted to higher energy forms using the energized electrons that were in NADPH. And then 2 of the 3-carbon molecules get to leave the system and become similar 3-carbon molecules, while the other 10 3-carbon molecules go back into 6 5-carbon molecules, and the system goes on and on and on. To explain respiration to you. Respiration first starts when glucose goes through a process called glycolysis. If there's oxygen, fermentation happens and your muscles kind of burn. This doesn't make any ATP, but it converts NADH into NAD+. If there is oxygen, though, NAD+ and 2 ATP become 4 ATP and NADH. Then there's this thing called oxidation deprivate, which is C2 plus CO2. In the mitochondrial matrix, 6 ATP becomes 6 ATP plus NADH and 2 NAD+ when the CO2 from oxygen deprivate leaves through the stomata. The remaining C2 joins the Krebs or citric acid cycle, and it joins 4 other carbon molecules, and then that C6 eventually loses 2 carbon molecules while turning FADH2 into FAD+, aka positive flavonine adenine dinucleotide. Molecules that are being lost, the carbon ones, are constantly being replenished throughout the Krebs cycle. The mitochondrial membrane, which is where this is all happening, is currently charged unevenly with negative electrons on one side and positive hydrogen ions on the other side. The negative electrons travel through ATP synthase, which makes just a few ADP into lots of ATP. Then 2 hydrogen atoms join 1 oxygen atom at the end and make water, and respiration is complete.